Hello 8th graders. In this IXL video we're going to be taking a look at assignment G1 that's called Converting Between Standard and Scientific Notation. Before we jump into these problems, it's important to understand what do they mean by scientific notation versus standard notation. Scientific notation is a method, or it's a way for us to write very large or very small numbers by using powers of 10. It turns out when we multiply by 10 or divide by 10, all that happens is a decimal point moves to the right or to the left. So we can use powers of 10 to write any huge or any small number as something that looks simpler and just uses powers of 10. So a very simple example here, standard notation is the way we've always written numbers. So if we write the number 5,300 in this way, the regular way we write numbers, we would call that standard notation. And 5,300 is equal, if we write it in scientific notation form, we could say 5.3 times 10 to the power of 3. And the big key here is that there's going to be a coefficient. And that coefficient needs to be between 1 and 10. So I'm going to put between 1.0 and 9.9 here. Make that a little bit smaller. And understand that the coefficient really, that's that number that comes first. Right here, it needs to be somewhere between 1 and 9.9. It has to be less than 10, but at least 1. It can't be a number smaller. And so we're going to go ahead and take a look here at this example. They give us 5.3 times 10 squared, very similar to the one we started with. But here there's only going to be 2 copies of 10 multiplied with that coefficient at 5.3. So what this is really saying is to do 5.3 times 10 times another 10. And if I do that, I'm going to just get 530. I'm going to talk in a second about how we got there. You could use a calculator to check if you don't believe me, but 5.3 times 10 times another 10 gives us 530. And what you're going to start to see here really is that at the end of the day, this decimal point just took 2 places, moved over to the right. We took 5.3 and we moved that decimal point 2 places to the right, and that's what gave us 530. And that's what happens whenever you multiply by tens. The decimal just slides over to the right, and that's why scientific notation is built on the power of 10. So our next one, how do you write 8.03 times 10 to the third in standard form? So again, this time they're saying take 8.03 and multiply it by 3 copies of 10. But all that's really going to do each time we multiply by a copy of 10 is the decimal point is going to slide 1 position right. So we're going to go 1, 2, a third spot, and we'll put a little 0 to hold there. So 8.03 times 3 copies of 10 is really just going to give us, at the end of the day, 8,030. Now, the other questions in this assignment, some will make you switch from scientific notation into standard form, but sometimes they're going to make you take something that's already in standard form, the way we've usually written numbers, and convert that into its scientific notation equivalent. So here we have 320,000, so I'm going to just go ahead and write that 320,000 out. And they want to know, how do we write it in scientific notation? Well, remember the big key, the coefficient, needs to be some power of 10. Sorry, something that's less than 10. So in this case, we're going to go with 3.2 because that's bigger than 1 but less than 10. So we moved that decimal point and placed it right here between the 3 and the 2. So I'll put that part of my answer up here. Now what we really want to see is how many places did we have to move the decimal point. The decimal point used to be right here at 320,000, and now we have it at 3.2. So if I count, I went 1, 2, 3, 4, 5 places to get that over there. So when I'm writing my answer here, 3.2 times 10 to some power, I'm going to need to make that power the power of 5, because 5 copies of 10 would change 3.2 into 320,000. And again, the way I understood that, the way I figured that answer out is I saw, well, I need the coefficient to be less than 10, so I put the decimal here to give me 3.2. But if I move the decimal point 5 places to the left, I need 5 powers of 10 to keep everything equivalent. Now we have another one that says scientific notation into standard form, which I think is a little bit easier. That's what you'll see we start with in class. If I have 8.9 times 1 copy of 10, I could write that out. I could say 8.9 times 10 and realize that that gives me 89. Or we could have recognized 1 power of 10. All we needed to do was slide that decimal point one place to the right to give us 89. Both methods work. They both get us the correct answer of 89. And now this one, 8.5 times 10 to the 4th. I'd ask you to pause the video and think about this on your own here. What would 8.5 times 10 to the 4th give me? And now as you're coming back from working that problem out on your own, if I have 8.5 times 10 to the 4th power, that really means I'm just going to take that decimal point and slide it to the right 4 times. And the first power of 10 is going to give me 85. I still have 3 more powers of 10, so I'm going to get 3 zeros attached to that 85. At the end of the day, we're going to be getting 85,000 here. And you'll notice there were 3 zeros attached, not 4 zeros, and part of that is because the first power of 10 needed to change 8.5 into 85, and then we still had 3 powers of 10 left over to add all those zeros. At this point, we think you're in good shape to be doing this assignment G1 on your own. I'm going to skip ahead to show some of the more difficult ones towards the end as we get closer to the challenge. But again, we think you're in good shape right now to go do this problem, or these problems on your own. So now as we move towards 75, not quite the challenge zone, but more difficult now, we see they just start to give us larger numbers. In this case, they gave us 9,782,000,000, pretty large number. So I'm going to go ahead and actually write this out here for a second first, just so I can make that a bit bigger. We had 9,872,000,000. I want to make that a little larger and easier to see. Now, if we want to write in scientific notation, we know that we need a number for the coefficient that is less than 10 but bigger than 1. And in this case, we could say 9.872. I put the decimal point right there. Now I have something that's not quite 10, but still bigger than 1. So that's what we require for that coefficient in scientific. And now I want to see how many places did I have to move the decimal point. We're going to switch over and we'll show that in blue here. The decimal point used to be at the end of the number, right at the end of the 9,872,000,000, and we moved 3 places, another 3, and another 3. So that's a total of 9 places as I jump that way. I went 9 spots. We could count that out. 1, 2, 3, 4, 5, 6, 7, 8, 9. But I think it's easier with the commas to just jump by 3s. 3, 3, 3. We jumped 9 total places. So we need 9 powers of 10, or we need to take 9.872 and multiply it by a 10 9 times in order to make 9,872,000,000. And you see, I've made a mistake. I was writing too quickly. And when I typed this number out, I did have that a little backwards. That's why we got to be careful on IXL. And I'm seeing in the explanation now as I read to that orange box at the bottom, my mistake was I wrote 9872 instead of writing 9782. So be careful as these numbers get larger. Try to avoid that mistake that you just saw me make. Or if you make a mistake, feel free to just go ahead and look at the solve box and they'll explain, oh, I swapped the 7 and the 8 accident. Alright, so 994 in scientific notation. They felt bad for me. They made it a little easier after that mistake. I'm going to just move the decimal 2 places. So I'm going to go ahead and write 9.94. And since I had to move the decimal 2 places, I need to get this 2 powers of 10 to get there. Now, we're going to look at 1 or 2 in the challenge zone. We think you're in totally great shape to do this stuff on your own, but here's a few examples from the challenge. The first one, this ridiculous problem here, they say, how do you write 5.7531 times 10 to the 14th in standard form? So here's how I would handle this. I know the decimal point's going to slide right for each power of 10. And I see here, when I take a look at this problem, I'm going to need to slide 4 places to the right to create 5,000 or 57,531. So that was by multiplying by 4 powers of 10. I turn this into no more of a decimal number, it's now a whole number, 57,531. But I still have a total of 1410, so there's 10 copies of those left over. I used up 4 of them, but there's still 10 of the 14 left. So I'm going to type 10 zeros in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can put commas in your number if you want to see what the number is. I'm doing that to just double check and make sure I didn't make any mistakes. And I do know 10 to the 14th should be somewhere in the 100 trillions, or in this case 575 trillion, 310 billion. Now, I'm glad we kept going on this video. Some of you may be saying, eventually they give us some of these crazy ones that it's a small decimal instead of a huge number. And here, when we multiply by 10, the decimal moves right. The inverse, when we divide by 10, the decimal moves left. So one thing I'm going to think about here is how many places would I have to move this decimal to get this to be 1.0, something that's scientific notation for. And if I look here, I have to count this out, zoom in even a little bit more. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then an 11th place to get here. So I moved 11 places. I'm going to put that in the exponent, but understand because we're going in the opposite direction, we have a very small number here. We need a negative power of 10. That 1.0979 is going to need to be divided by a copy of 10 11 times to create this really tiny decimal number that we see. And at this point, we're not going to keep going any further. We'll show this one very quickly, but it'll be the last one we show. But we just think they do get tough at the challenge zone. But once you understand the system, just count your zeros, count your places, and okay. In this case, we see 1.4378 times 10 to the power of 10. I'm going to again figure out, I need to go 1, 2, 3, 4 places just to get to 14.378. So after I multiply by 4 of the 10s, I have 14,378. And I still have 6 more of the 10s left over, because I need to use 10 in total. So I'm going to put 6 zeros onto that number. And at that point, we're not going to keep going further in this challenge zone. As you see, they give you either really tiny decimal numbers or gigantic scientific notation numbers. But just count your zeros, count your place values, and then the challenge zone. Okay? But if you do have questions, you could always email me. I am ddoherty3 at bostonpublicschools.org. Thank you for watching to the end of the video. We hope this was helpful. Keep up the great work on IXL.